Today on the Standing on the Shoulders of Giants podcast, we are going to put our head in the clouds and talk about the cloud itself, understanding what exactly the cloud is and how do we access it and what exactly is it doing these days. My name is David Mackay. I'm the host of the Standing on the Shoulders of Giants podcast. For those of you watching, although not everybody watches, you'll notice a little mark on the left side of my face here, and nothing to worry about, just a little rough jiu-jitsu session. Other than that, tip-top. On the cloud front, there is a number of different things these days. Specifically, we've got the big three clouds, namely Google, Amazon, and Microsoft, although there are other cloud providers in other different senses of the word cloud, namely Cloudflare and DigitalOcean and Linode. One of the things I did want to talk about, though, is the definition of the cloud itself, and to sort of clear this up, because I note that people have asked me this on a number of different occasions, wondering what the cloud actually is. And the answer to the question is other people's computers. Plain and simple, that's all the cloud is. It is other people's computers. Instead of running a particular piece of software on your computer, it runs on someone else's computers. Instead of storing your information and your data on your computer, it's stored on someone else's computers. Things like iCloud and Dropbox are what we would call storage in the cloud, because it's not stored on your computer, and even if it is, a copy is kept in the cloud. So, now that we've identified what exactly the cloud is, why don't we understand how did we get to the cloud? First and foremost, imagine this. Imagine mentioning someone in the 19th century that all of your most important data, that all of the things that you find extraordinarily valuable, not only are they kept on your phone, which would be a confusing statement, but they're actually kept in the cloud. And then, of course, imagine them gazing upwards in bewilderment, wondering what in God's name the future holds for them. The truth of the matter is that the cloud is effectively just a part of the internet. And when we say just other people's computers, what we mean is the three main cloud providers, although lots of other cloud providers, they have storage and compute and internet all over the world. By storage, what we really mean is hard drive space. So the ability to store your files and or programs and various other things that you want to keep around and keep backed up. They keep those in their data centers around the world. Data center being just a gigantic warehouse with lots of power, lots of internet, and lots of cooling usually to keep these thousands and thousands, even tens of thousands of machines up and running and again around the world. And when we say around the world, there are hotspots for lots of different compute. There are places like Virginia in particular, Northern California, Singapore, London, Amsterdam. Those are some internet hotspots where lots of major companies end up putting their particular applications and putting their main hotspots for whatever it is that they're running out there on the internet. Effectively, it is a vast network of servers accessible over the internet, providing storage, processing power, and software applications. And again, this is just other people's computers. That's the easiest way to define it. When your iPhone is backed up to iCloud, it just means that your photos and videos and the like, settings and all the other things that you've backed up to iCloud are sitting on Apple's computers somewhere. And not only that, but it's not one copy, it's multiple copies, usually sitting on Apple's computers in a number of different places throughout the world. Because of this, you're able to access them anywhere in the world, and that is one of the powers of the cloud. Just like you don't need to understand the intricacies of sort of the electricity for how to use a toaster, you don't really need to understand the intricacies of the internet or cloud computing to understand how to use the cloud itself. Personally, I've actually worked at 3 different cloud companies. I've worked at DigitalOcean, which is a medium-sized cloud company out there. I've worked at Google, one of the main cloud companies, and I worked at Microsoft. One of the other main cloud companies, the only one I haven't worked at present, is Amazon, although I've used their services quite a bit. There are different types of cloud models, and I'd love to be able to go through those today. I'd like to be able to go through not only the cloud models for individual use, so consumer use, but also for commercial use, and really understanding what these look like. So when we understand cloud services, we understand them to be three main different types of models, and that is IaaS, PaaS, and SaaS. That is infrastructure as a service, platform as a service, and software as a service. As consumers, typically speaking, we're using software as a service very often, platform as a service not very often, and infrastructure as a service almost never, although oftentimes our software as a service companies are utilizing the first two tremendously. Infrastructure as a service is effectively renting your own virtual servers and storage, allowing you to build and manage your own infrastructure without the hassle of any of that physical hardware. Previously, when one was doing a startup in the software world, you would have to go find servers and internet and all sorts of things that were, quite frankly, a bit of a pain to end up going to get. But when you would go out to get those things, that was necessary for you to even run your service. These days, that's no longer necessary. You can rent these things, like I said, from various cloud providers, but the three main ones being Google, Amazon, and Microsoft. You can rent those such that you don't need to buy your own physical gear to be able to deploy your application. An example of this, for instance, is Spotify. Spotify uses one of the three main clouds. Specifically, Spotify uses quite a bit of Google Cloud. There are other services that do this. For instance, Netflix specifically uses quite a bit of Amazon's cloud. And so they don't need to maintain a tremendous amount of physical infrastructure, although sometimes they do. And we'll get into what exactly that is later. There's also platform as a service. Platform as a service, which is the second model we discussed, is basically a platform ready to use for developers that provides tools and resources to build, test, and deploy applications without worrying about the actual infrastructure management. Now, the difference here between platform as a service and infrastructure as a service is that platform as a service is usually running on infrastructure as a service, but provides abstractions such that you don't need to understand exactly how to deploy things or what physical characteristics you need to give your applications such that they're redundant around the world. Finally, there's software as a service. Software as a service just means accessing software applications throughout the cloud, eliminating the need for installation and maintenance. I've worked with all three of these models in a number of different capacities. In particular, I've actually managed an infrastructure as a service platform, DigitalOcean, which is one of the cloud providers. I've had some experience with a platform as a service known as Heroku, and this allows you to deploy to clouds without actually needing to know the intricacies of how to operate the clouds themselves. And finally, software as a service is something that all of us have used for quite some time. You can think of it as things like Salesforce, Dropbox, or iCloud. In fact, most software that you would use these days that you would access via your web browser, most of that would be considered software as a service because your data doesn't sit on your machine, nor does your machine really do any processing other than to render the data to you, as opposed to actually process and crunch that data. That's usually done on the software as a service infrastructure. Some of the everyday uses of the cloud, as we've already discussed, are cloud storage. For instance, you would store your photos, videos, and files and be able to access those on multiple devices. Of course, a good example of that we've already spoken about is Dropbox. Email and collaboration. Now, what's interesting about this one, just as a personal anecdote, is that I worked at Hotmail all the way back in the 90s. And the thing at the time was most people did not access their software on the web. Most people accessed web pages on the web, and it was mostly used for reading. It was effectively a digital magazine at the time. Software really hadn't made its way to the web other than to make things available for people to read. Computing was still done on your computer. When you wanted to use Microsoft Word, or for that matter, some other word processor, or anything of the like, you would download that piece of software, pay a license for it, and then run it on your operating system. When you saved it, it would be saved to your laptop. These days, if you use something like Microsoft Office 360, or for that matter, Google Docs, you can download that, but a copy of that exists in your Office, Microsoft Drive and Office, or your Google Drive and Google Docs. Hotmail in particular was one of the first things ever to actually bring software to the web itself. What's notable about this is that at the time, Microsoft bought Hotmail, it already owned several clients and, for that matter, servers to utilize email via your desktop. In particular, two of the main ones would be Exchange, which was an email server that you would run on your servers to be able to do email back and forth as a company, and Outlook, which is a client to be able to send and receive emails. That said, Hotmail was available via the web, and again, one of the first instances of software as a service. One of the first instances of something that was a paid-for software as a service was something like Salesforce, which was made available in 1999, and again, accessible via the web, one of the very first things to utilize this software as a service. And finally, as far as consumers are concerned, another everyday use of the cloud would be something like entertainment streaming, something like Netflix or Amazon Prime or the like. You can see movies and TV shows and music like Spotify or, for that matter, a podcast, what you're listening to right now, through these cloud-based streaming platforms. Again, I've had a number of different experiences with each one of these, and I'm sure you have as well. There are, however, some cloud applications and peripherals we should also dive into. For instance, there's something called the Internet of Things. This basically connects devices to the cloud for automation, control, and data collection. If you've heard of something called smart cities, or for that matter, smart homes, where a number of your devices inside of your home now connect to Wi-Fi, and they use that Wi-Fi for various services. For instance, something like Google Cameras or a Google Nest for your thermostat, or an Amazon Alexa, or for that matter, an Apple HomePod. Each one of these represents a thing, and it would be considered to be the Internet of Things. They also represent virtual assistants, which is another cloud application and peripheral, like Siri or Alexa or Google Assistant. That said, all of these things represent the new smart home technology, and they're all reporting back effectively to the cloud, reporting back data for automation and control, and again, allow you to change, let's just say in the case of a Google Nest for your thermostat, allow you to change the temperature remotely even when you're not home. There's also a number of different other things that you could end up saying that the cloud connects into, but these days, it's not always fun and games. There are multiple instances when Amazon in particular, which is the largest of the three clouds, has had one or two issues. These issues highlight one of the drawbacks of the cloud in that even though you're saving tremendous amounts of money by utilizing the cloud and things become easier to use and easier to deploy as a startup, it also means that tremendous amounts of people are using those. So when Amazon itself has a problem in the cloud, it means that it's taking down tremendous amounts of the internet. There was such a time in 2017 when Amazon took down roughly half of the internet, or what we would say is half of the usable internet. A huge amount of sites were not available to be used. Even sites that didn't necessarily directly use Amazon were not able to be used as well, because some of the services that they relied upon were actually dependent on or deployed in Amazon's AWS. So it's not necessarily always fun and games when we talk about the cloud itself. There are some interesting futures for the cloud in artificial intelligence and machine learning. This would allow cloud computing to do advanced AI and ML applications accessible to all. Now, the issue here is that it requires tremendous amounts. For instance, something like ChatGPT or any of these large language models, it requires tremendous amounts of computing power. In particular, it requires tremendous amounts of GPUs, otherwise known as graphical processing units. A main computing chip is usually called a CPU, or central processing unit. These CPUs, things like Intel and AMD or Apple's M1 and M2 chips, these chips are excellent at just about everything, but they're not specialized. They're not phenomenal. GPUs are phenomenal, in particular, at linear algebra, which is the basis for a lot of the artificial intelligence and machine learning that you have out there. And it's because of all the vector math they have to do to render things to the screen, hence why they're graphical processing units. There's lots that the cloud is able to do there. And in particular, the cloud is able to do these things because of economies of scale, meaning when you're buying 100,000 units of something, the next 100,000 and the next 100,000, especially if you're doing it at a reasonable pace and you're able to deprecate things and have them depreciate in the correct fashion, especially when you combine those with models that financial departments would put together, then what would end up happening is you're able to utilize these massive economies of scales to buy things on very low rates of cost and thus lock everybody else out, which is also a little bit nerve-wracking in the cloud. But unless you're in the cloud space directly, it just means that things will end up being cheaper for you to do when you're doing your advanced AI and ML processing. Another thing that would be interesting is edge computing, which we've started to get closer to. Basically, this is processing data itself closer to the source, reducing latency and enabling some of these real-time applications. Now, as fun as this sounds, I think some people might get a little bit confused by this in the sense of the speed of light isn't as fast as you think it is. It's not quite instantaneous. Round trip time from here, meaning Austin, Texas, where I am, to somewhere like India, would be around 400 milliseconds on the internet. 400 milliseconds on the internet would be considered a lifetime for gaming applications. In fact, it would be considered roughly unusable for a number of different gaming applications, especially where real time is necessary. Things like shooting games and games where there's real-time feedback between players, massive amounts of lag, as it's called, or latency, have real effects on gameplay and usability for users. So edge computing aims to stop this by having things in major metropolitan areas. For instance, right now, for some of the games that I play, I would have to connect to either New York, Virginia, or I'd have to connect to California. But being in Texas, it would be advantageous for me if there was actually something in Texas I could connect directly to. And again, this is what a lot of these cloud players are doing, is bringing these edge processing and edge compute even closer to the end user, such that latency and feedback time is near real time. Also, security and privacy is continuing to evolve in the landscape of the cloud, and cloud security is top of mind for a tremendous amount of folks. Now, most of the three, I should say all of the three major clouds have nearly every one of the security certifications that you can imagine. Things like HIPAA and SOC 2 and PCI, etc. These are all extraordinarily important to large corporate businesses. But security and privacy goes beyond that. It's not just about having the actual certifications themselves. It's about actually being secure in the cloud. If you are on a virtual machine, which is effectively just a machine that's carved up, the resources are carved up such that they look like separate machines, but they're separate not physically, but only logically via the software itself that runs on those machines, you could be literally sharing a machine in AWS or one of the other major clouds with your direct competitor, and you would never know it. Again, this is nerve-wracking for certain people, especially depending on the field that you're in. If you're in something like healthcare, HIPAA is extraordinarily strict on understanding how patient data is to be shared and to be stored. And so having this real-time security and having these breaches that occur from time to time on the cloud, these are things that are all extraordinarily negative. But the clouds, typically speaking, have done a really good job in trying to mitigate a number of these things, top to bottom, with hiring security teams and firms. One of my recent interviews with a gentleman, a good friend of mine, Scott Longhire, and he was discussing industrial network defenses. And the cloud, it's possible that could end up being considered an industrial network at some point in time. The reason I would say that is, right now what we consider to be industrial networks is something like the utility grid, like gas and power. But there was an American computer scientist very early on, meaning the early 60s, before the birth of the actual internet, who theorized something like utility computing. His name was J.C.R. Licklider, often known as Lick. And Lick in particular thought that the computing grid eventually would be something like the power grid, where you would be able to not only democratize, but effectively commoditize access to this. And this is roughly what the cloud has been. So he ended up sort of visualizing the cloud back in 62, 63, which was pretty impressive considering that the ARPANET, which is the predecessor to the internet itself, hadn't even been built yet. So again, Very interesting stuff. I've had a number of different forays into each one of these realms that we've just discussed, including the artificial intelligence, edge computing, and security and privacy. But in particular, my view of the cloud is at some point in time, it will be extraordinarily commoditized. It won't really make a difference which cloud you're on. Although they do all have their strengths today, my guess is that towards the future, things will not be stronger nor weaker no matter which cloud you're on. It will effectively be like trying to choose which utility provider you go with in terms of your energy for your house. And the answer there is it doesn't really make a difference. You're more concerned of which one is the most stable and the mean time between failure, or MBTF. That's really all you're really concerned about. Most of the rest of the stuff probably won't have that big of an impact. I believe that the cloud is going to have a significant impact on society. I believe that going forward, it's going to be effectively central to the internet, and it is pretty much today. But going forward, especially as we look towards things like artificial intelligence and machine learning, bringing that technology to the edge and being able to make real-time decisions based upon it, again, I would argue that you could make smart cities extraordinarily smart. I would argue that you could make smart homes extraordinarily smart beyond what we're even capable of thinking of even at present, and being able to anticipate certain decisions. Imagine something like New York City being able to put one of these in a New York City cloud, having edge compute and taking real-time Internet of Things data from every single solitary stoplight and wait plate placed around the city such that it's able to optimize traffic nonstop, such that it's able to immediately call ambulances for suspected injuries in traffic accidents that it detects via cameras or even just via sound on the lights themselves. Honestly, I think you could end up going quite a long distance thinking through this. But regardless, I believe that the future of the cloud is going to be everywhere, and it's going to have a gigantically huge impact. This is just my futurist self talking, but I believe that we'll be able to do some really amazing things with this going forward. This has been a bit of a podcast on the cloud, a little short one today. I hope you've enjoyed this podcast, and you like and subscribe, and appreciate your time. Thanks, everybody. Until the next time. We have been standing on the shoulders of giants. Thank you.